So in this video, we're going to cover the ethical issues in research. I'll cover briefly on the protection of human research subjects and cover other areas of scientific misconduct, and then introduce you to the concept of the SF&O method, which is the stakeholders, facts, norms, options methods of analyzing cases of scientific misconduct. So if you're in my undergrad or graduate level research methods course, I have every student take what's known as the Human Research Subject Certification, either through the NIH or through the Collaborative Institutional Training Initiative, or CITI, and both courses, online courses, do a very good job of covering every aspect and ethical considerations of protecting human subjects in clinical research. So I'm not going to spend a whole lot of time on that here, but what I want to at least introduce you to the concept of informed consent. Here's a photo from the CDC. This is a photo taken from the Tuskegee syphilis study that was, I believe that was over 40 years. It started in 1932, and the researchers from the U.S. public health system observed mainly African American males from Tuskegee, Alabama, who had a high prevalence of syphilis at the time. The study was a direct violation of the rights and welfare of this research participant because treatment was withheld from them, even though an effective treatment was available. So as early as 1945, penicillin was available. As a result, over 100 participants died, unfortunately, from complications from syphilis. So in 1974, after it went public, the United States government formed a National Commission for the Protection of Human Research Subjects in Behavioral and Biomedical Research, and passed the National Research Act in 1974, which established IRBs, or institutional review boards, across the country in every university or most university institutions, and their main objective is to oversee and protect human participants in clinical research, with the informed consent being the heart of that protection. So we'll go over that in a sec. So during the course of the deliberations, the National Commission came up with what's known as the Belmont Report, which lists 3 ethical principles that is associated with protecting human subjects. One is respect for persons. That means that individuals have full autonomy. They should be treated as autonomous agents to make their own decisions, to participate or not participate in a research study, or to withdraw from a study if they feel inclined to do so. It also means that persons with diminished autonomy are entitled to protection. These are patients, potentially, that may have mental health issues, or children who may not have the capacity to make their own decisions. So respect for persons involves treating human participants as autonomous agents, or protect those with diminished autonomy. Another principle is beneficence. Beneficence involves researchers to maximize potential benefits and minimize the risk of harm in these human subjects, in these research participants. That means every participant should not be harmed when participating in a study. It sounds like common sense, but it is an ethical principle that is an important part of making sure, or ensuring, that these human participants are protected when participating in a research study. Justice. An ethical principle of justice simply means that these benefits and risk are distributed fairly, that is equitable. So regardless of the demographics, or the ethnic background, or the socioeconomic status of these participants, all of these benefits and risks would be equitable among all of these research participants. So these 3 ethical principles form the foundation on which human subjects protection is based, that is communicated through the informed consent. So the expectations is, when dealing with, or including human research subjects in our clinical research, is the right to privacy or non-participation. Like as I mentioned earlier, they have the right to choose not to participate in a study, a right to remain anonymous, right to confidentiality in their data that's been collected, as well as their identification information, and the right for the researchers to be responsible for their well-being and safety when participating in a research study. So this led to the establishment of the Collaborative Institutional Training Initiative, as I mentioned earlier, the number of institutional review board, and the informed consent, which includes, among many elements, 7 main elements that go to protect these human subjects. This includes a fair explanation of the procedures, a detailed explanation of the procedures, a description of all the risks or discomforts that these human subjects may have when performing the task involved or the procedures involved with the study, description of any benefits, both indirect and direct benefits that are expected from the study itself, a disclosure of alternative procedures that may be beneficial to participants if they can't participate or perform some of the aspects or some of the procedures that described or required for the study. Provide ways of communications to make sure that questions can be answered, any inquiries that the human subjects have, and so that the researchers or the PI, the investigators, may be able to communicate and answer them in a timely fashion. And an instruction that the participant is free to withdraw at any time for any reason. So as a result of these ethical principles and guidelines, human participants have expectations that include the right to privacy, or the right to choose whether or not to participate in the study, the right to remain anonymous, or the right to confidentiality of their data, as well as their identification information, and the right to the responsibility of researchers to ensure the health, safety, and well-being of these human research participants. All of these expectations should be communicated through what's known as an informed consent form. And this informed consent form, or an ICF, should include elements such as a fair description and detailed description of the procedures to be followed in the study, a description of the discomforts and potential risks that are inherent in the procedures and equipment, description of both direct and indirect benefits of the study, as well as its research findings, a disclosure of alternative procedures that may be beneficial for participants, especially those who may not be able to perform all or some of the procedures described by the researchers in the study, an offer to answer any inquiries, the mode of communication for the researchers, so that whatever questions or inquiries the research participant may have, that they may be answered in a timely manner, as well as an instruction that the participant is free to withdraw from the study at any time for any reason. So now let's discuss other areas of scientific misconduct, which is defined by the Federal Register as fabrication, falsification, or plagiarism in proposing, performing, or reviewing research, or in reporting research results during the normal course of a research study, nor does it include differences of opinion. Scientific misconduct could include, as I mentioned earlier, fabrication, falsification, plagiarism, non-publication of data or cooking data, faulty data collection procedures, poor data storage and retention, as well as security of storing and retaining research data. Another area that's of concern in terms of scientific misconduct, potential scientific misconduct, is misleading authorship. We need those individuals who contribute directly and substantively to the completion of the study or the writing of a manuscript should be listed as an author. A technician that assists in data collection or in cleaning or a little bit of an analysis typically are not listed as an author. So what I recommend for graduate students in particular is to work with your faculty advisor. Make sure you discuss the issue of authorship right off the bat, because that leads into the next area of concern for scientific misconduct, which is publication. like who gets to publish it after the study is done? Do you publish it as a lab, as the lead author, which should be you as a graduate student if it's for your thesis or dissertation, followed by your faculty advisors. So again, authorship is an issue here, especially if you are performing a thesis, a capstone, or dissertation. As I mentioned, you as the lead investigator, the primary investigator, should be listed as the first author for whatever publication you plan on potentially submitting and getting accepted by either a peer-reviewed journal or presented at a scientific conference. So again, make sure you discuss amongst your faculty members, or your faculty committee, as well as your cohort members in terms of authorship of a research study. Okay, so a model for considering scientific misconduct. There are a couple of avenues here. I'm just going to go over, one or two areas in which scientific misconduct is addressed. One is through sanctions by the university or institutions and other punitive efforts in order to clamp down on the misconduct conducted by, or allegedly conducted by, either faculty members or graduate students. In terms of mistakes, there are remedial or learning activities that potentially reduce or minimize the risk of mistakes performed in a scientific research. So the best way to address scientific misconduct is to understand the root of the problem and understand why scientific misconduct happens in the first place. There's a lot of pressure, especially as a graduate student, to complete your work, whether it's your dissertation, your thesis, your capstone, by a certain date. You want to graduate on time. For faculty members, they want to get funding. They want to continue their grants or academic rewards. So there's this pressure to publish, especially among faculty members and graduate students at an R01 institution, where this whole publish or perish environment is there, where you constantly have to publish in order to satisfy requirements for promotion, rank, and tenure. So there's a lot of publish, which may lead, unfortunately, for researchers to either fabricate or falsify data. Fabrication is simply making up results, making up data in terms of recording and analyzing and reporting them. Falsifying is when you manipulate data, or manipulate equipment that leads to a certain outcome or desired outcome. So this is a serious issue with scientific research, and unfortunately we find cases in different areas of research in which researchers have been proven guilty, if you will, of falsifying or fabricating data. There have been cases where studies that were published in peer-reviewed journals had to be retracted because of a discovery, either through a whistleblower or through someone performing the analysis themselves, that the data that was published was fabricated and or falsified. So one method that can be used to address these cases of scientific misconduct is what's known as the SFNO method, where S stands for stakeholders, who are the individuals who have interest in the decision being made regarding the scientific misconduct. These are the researchers, the administrators of the institution, the department heads, the research participants themselves, because they may have a stake in the knowledge that is gained from potentially gained from the research study, or the population from which those participants are drawn. Those could also be stakeholders, right? F stands for facts. These are the facts that we know regarding a particular case of a scientific misconduct. Which facts might generate disagreement, which facts may change the outcome of said scenario, which leads to the norms. How can these facts be evaluated? We have to have ethical principles. We have to have ethical norms. As I mentioned, this include respect for persons, beneficence, justice, any professional codes or laws that are detailed and specific to an area of research that governs the way research should be conducted in that particular field or area. And then O stands for options. What are options that are available to rectify the scenario or to lead to a better outcome so that this scientific misconduct can be prevented and for future research from the same institution or for potential from the same group. The way you can remember this is SF and no. Use this acronym or use this moniker. So far, no objections. All right. So when you're dealing with these cases, use the SF and no analysis for stakeholders, facts, norms, and options. So, for example, I'm going to help you out here. I've got here Dr. Wade. He's a lot of pressure to submit an ACSM abstract by the due date. Let's say it's tomorrow, and then you realize that the sample didn't show a significant increase in strength. And so he went back to the data, he looked into his data sheet, his SPSS file, and found that 15 participants did improve in terms of strength, but 5 did not. So he decided for whatever reason that they didn't adhere to the training, they didn't comply, so he dropped them, even though he didn't have any evidence or proof that they didn't comply because it wasn't followed. So after taking that 5 subjects out of his sample, he ran the analysis again and did find that there was a significant increase in strength. So based on the information you know here, did Dr. Wade acted unethically or ethically? So what I want you to do is use this SF&O analysis in order to evaluate this particular scenario. Identify the stakeholders, the facts, the norms, as well as the options available. So give it a shot.